All right, welcome back to linear algebra. Let's jump into Anki. Oh man, we got a lot. Must the inverse of an invertible triangular matrix be a triangular? Yes. How are the columns of a matrix A affected if it is multiplied on the right by a diagonal matrix D? Each successive column is multiplied by each successive diagonal entry. Must the product of lower triangular matrices be lower triangular? Yes. What is a symmetric matrix? Symmetric matrix is one in which A equals the transpose of A. It's a square matrix as well. What must be true for a triangular matrix to be invertible? The entries of the main diagonal must be... The entries of the main diagonal must be non-zero. What must be true for the product of two symmetric matrices to be symmetric? They must commute. What is an upper triangular matrix? A lower triangular matrix? A triangular matrix? An upper triangular matrix, lower triangular matrix, and triangular matrix. Upper triangular matrix is a square matrix in which all entries below the main diagonal are zero. Lower triangular matrix is a matrix in which square matrix in which all the entries above the main diagonal are zero. A triangular matrix is a square matrix in which is either an upper or a lower triangular matrix or both. If A equals bracket A sub ij is a symmetric matrix, what is the relationship between A sub ij and A sub ji? They're equal. Must the product of an upper triangular matrices be upper triangular? Yes. How are the rows of a matrix A affected if it is multiplied on the left by a diagonal matrix D? Rows of a matrix A. How are the rows of a matrix A affected if it is multiplied on the left by each successive row is multiplied by each successive entry of the diagonal? Must the inverse of an invertible symmetric matrix be symmetric? Yes. What is a symmetric matrix? It's a square matrix in which A equals AT. Or the matrix equals the transpose of the matrix. Okay. Boom. Now, what did we learn about yesterday? Okay. We read a section on matrix transformations. Okay, and so a linear system can be written as a matrix equation, right? Which is AX equals B, where where B and X are both column vectors. Now, this is a matrix equation, but we can also think of it as a transformation from X to B. And the transformation being the function multiplying by matrix A. And so we can rewrite this or think about this not as an equation but as a transformation. And so there's a few ways to represent this. So we could say T of A colon x, no, Rn to Rm, meaning a domain to codomain, potentially, but also T of sub A of x equals B. You can also say x arrow B and above the arrow being T of A. Okay, we got more clear on what R to the power means. It's really talking about all the potential ordered pairs or ordered n tuples of a given number. So R squared would be all potential real number ordered pairs of real numbers. R cubed would be all potential the set of all potential ordered triples of real numbers. Okay. Zero transformation. This is t sub 0. It's like the same as multiplying by 0, so it's going to turn any number, any transformation is going to end up being a 0 from Rn to Rm. And identity operator denoting that m equals n, so it's basically like multiplying by I, and Rn is going to equal Rn. Oh, yeah, yes. Well, not necessarily Rn going to equal Rn, but like the value in Rn is going to equal the value in Rn. Okay, the X arrow W or B with CA above the arrow, that's schematic form. Okay. We can also say T sub A maps X into W. All right, so that's good. I'll continue reading now about properties of matrix transformation. I'll be back to recall what I learned a little bit. All right, so I learned about 4 properties of linear transformations today. One of them is T of 0 equals 0. This homogeneity property in which T of K times A, where K is a scalar, A is a vector, equals K times T of A. Additivity, T of A times B equals T of A times T of B. No. T of A plus B equals T of A plus T of B. T of A minus B equals T of A minus T of B. Oh my gosh, all right. So it's getting more complex. These linear transformations, I think to be a linear transformation, it has to have all those 4 properties. And there's something about, there's other types of transformations. So linear transformations, I think, are very similar to matrix multiplication. But there's other types of transformations. And so no, these are matrix transformations. There's other types of transformations other than just matrix transformations. All right, anyway, that's it for today. Talk to you tomorrow. See you.